Review on application of drone in spraying pesticides and fertilizers. Abstract: in today's agriculture, there are far too many innovations involved. One of the emerging technologies is pesticide spraying using drones. Manual pesticide spraying has a number of negative consequences for the people who are involved in the spraying operation. The result of exposure symptoms can include minor skin inflammation and birth abnormalities, tumors, genetic modifications, nerve and blood diseases, endocrinal interference, coma or death. However, drone can be used to automate fertilizer application, pesticide spraying, and field tracking. This paper provides a concise overview of the use of drones for field inspection and pesticide spraying. Displays different methodologies and controllers of agriculture drone and explains some essential drone hardware, software elements, and applications. Keywords: drone technology, spraying pesticides, crop monitoring. 1. Introduction. The explosion of the human population makes high productivity, high performance, and sustainable agriculture more important. 1. In the modern environment, agriculture is essential for the subsistence of more than 60% of total of the world's population. 2. It is a critical element in the protection of the environment in the developed world. The agricultural modernization is mandatory when demand and food supply are increased. Drone are one of the most advantageous equipment for modern agriculture. The pesticides and fertilizers are critical components in the control of insects and the development of crops. Spraying pesticides and fertilizers by hand causes tumors, hypersensitivity, allergies, and other illnesses in people. Hence, drone can be used to automate fertilizer application, pesticide spraying, and field tracking, which is also used for many applications such as search and rescue, police, code inspections, emergency management, fire. Other advantages of drones include their fast maneuverability, improved payload, high lifting power, and stability. 3. It comes with a universal sprayer for spraying both liquid and solid contents. The global nozzle sprays all pesticides and fertilizers, but the tension pump is only used when spraying pesticides and not when spraying fertilizer. In wide fields, the GPS can be used to automatically direct the quadcopter and power it remotely. A quadcopter is piloted by an autopilot controller, and the payload is driven by an RF transmitter and motors. The figure 1 illustrates the pesticide spraying mechanism. 4. This paper usually depicts the characteristics of appropriate drones for a particular agricultural purpose. Furthermore, it will be clear as to which drone archetype is needed for specific farming tasks. The systematic review of this article is based on basic keyword and abstract searches in Scopus, WOS, Web of Science, and Google Scholar databases. Several trustworthy websites were also consulted for subject-related material. 2. Literature review. Yalapa, 2017, improved in hexacopter with 6 BLDC motors and 2 LiPo batteries of 6 cells 8000 mAh. Their research also includes a performance assessment of spray liquid discharge and pressure, spray liquid depletion, and droplet size and density determination. By means of their project, they eventually created a drone that can hold 5.5 L of liquid and has a 16-minute endurance period. 5. Donjian, 2015, investigated successful swath width and droplet distribution uniformity over aerial spraying systems such as the M18B and Thrush 510 Guaranis. The agricultural planes flowered respectively at 5m and 4m high, and by this experiment they conclude the disparity in swath width of M18B and Thrush 510G in flight height. 6. Professor B. Balaji, 2018, created a hexacopter UAV for pesticide spraying as well as crop and environmental surveillance using Raspberry Pi and the Python programming language. Their UAV also has a variety of sensors, including DH11, LDR and water level monitoring sensors. As a result of this experiment, they eventually concluded that with proper implementation of UAVs in the agricultural sector, savings in terms of water, chemical abuse, and labor can be projected to range between 20% and 90%. 7. Kirkut, 2018, used basic cost-efficient equipment to work with UAV quadcopter and its spraying system. Spraying with both liquid and solid material is done using the universal sprayer method. During their analysis, they also compared various agricultural controllers and came to the conclusion that the quadcopter system with the Atunga 644 PA is the most suitable due to its successful implementation. 8. Huang, 2015, developed a low-volume sprayer that can be used in unmanned helicopters. The helicopter has a 3m main rotor diameter and a payload capacity of 22.7 kilograms. It used to take at least a gallon of gas every 45 minutes. This research paved the way for the development of UAV aerial application systems for crop production with a higher goal rate and a larger VMD droplet scale. 9. Shilpa Kidarai has suggested a low-cost, lightweight quadcopter, QC, framework. The quadcopter is also known as Unmanned Aerial Vehicle, UAV. This quadcopter is compact and can be used for both indoor and outdoor crops. The quadcopter is an unmanned flight that uses an Android smartphone to spray pesticides and fertilizer. The contact between the quadcopter and the Android smartphone is achieved in real time using a Bluetooth device. This method is used to reduce agricultural field problems while still increasing agricultural yield. 10. Sadhana improved on the above approaches and created the quadcopter UAV and shower module, which can be used to spray pesticides in agriculture fields to increase efficiency and protect materials. The total load for this project is 1 kg and is used to spray low-altitude pesticide quadruple copter lift. The Arduino Uno at MEGA 328 and brushless direct current, BLDC, electronic speed control, ESC, MPU 6050, which combines a MEMS accelerometer and a MEMS gyro into a single chip, radio receiver, LiPo battery, and pesticide spraying module control this quadcopter. 11. 3 methodologies and materials. Methodologies. The main board in the drone is the flight controller, which is loaded with cutting-edge firmware and is in charge of the actual flight. The flight controller controls a lot during the flight or drone at the same time. It has been designed and connected with a microcontroller to the 4 motors without brush motor. BLDC motor attach in the drone setup model with the rotors. These BLDC motors are controlled by the electronic speed controllers, ESC. The drone is powered by the transmitter and receiver of the radio network. There are several platforms for individual drone control activities for any RC transmitter. A sample block diagram shown in Fig. 4. Different methodologies and controllers of drone are shown in Table 3. The quadcopters enable the fabrication of unique folding frames for safe transport and convenient packaging of cylindrical cushioned boxes. Accelerometer, gyroscope, IMU, infrared camera, BLDC, ESC. Drones are an array of sophisticated hardware, software, and advanced technology. In general, many software and hardware components are used to properly control the drone according to drone's startling variants. The unified body or structural components are usually referred to as hardware. Drone hardware shows the technical components of the drone enough and takes software applications guidance. Furthermore, the software may be referred to as a drone's brain. The software is supposed to tell the drone whether or not to go and what to do. As a potential method of speculating and combining all of the drone's critical data, a complicated structure benefits from the software portion. Drone software consists of a large number of different applications, processes, and operations. It also has a specific liability, as shown by its hardware components. The drone is correctly controlled by a special combination of hardware and software. Tables 1 and 2 show some of the underlying hardware and software components respectively.